Hey guys, welcome to day 7 of the 28 days challenge of data science, AI, and Gen AI. So, today I'm going to talk about the model evaluation. How do we do the evaluation, right? Before I talk about the model evaluation, let me introduce myself. It's me again, Mahesh, with 14 years of experience in data as a data architect, data engineering, data science, data trainer, right? So in day 7, before I start the deep learning, I thought about talking about evaluation, because I have got few queries around it where people have asked me like, what is evaluation and how do we evaluate. So what I have done, I have used a totally different kind of model, totally different kind of data set, which makes easier to explain about evaluation. Okay, so I'm going to go to the slides first, right? And then as we have done, so I'll show you the code too. But before that also, I'm going to do some notes for yourself so that you can able to understand what is evaluation and all. Okay, so let me move to the next slide. So the model which I have used here is logistic regression. Okay, logistic regression is one of the most easiest kind of classification model which is available in the market. Okay, just go ahead, just use it. It is super easy to implement, super easy to understand. If you don't know, I'm going to show you in the notes what is logistic regression. Okay, so the data set which we are going to use here is Titanic data set. It's again very commonly known data set. So it is a data set of the customer who were there in the Titanic and what happened to them. Did they survive? Did they didn't survive? So we'll try to identify or predict who did survive. Okay, so when we think about evaluation, when we think about matrix, right? So we think about understanding whether the given model is a good model or not a good model. So based on that, right, we try to find different kind of matrix and different kind of parameters around it. Okay, so when we think in classification model, right, we have some set matrix. For example, accuracy, precision, recall, and F1 scores, right? Accuracy is the most used matrix. Precision, recall comes along with it. Okay, depending upon what kind of type, what is it, are we trying to handle the type 1 error or type 2 error, okay, which I'm going to talk about in the next stuff. So if we want to put forward all the things, right, it's very easy to put forward in the confusion matrix. Based on the confusion matrix only, we try to derive our accuracy score, precision score, recall score, and F1 score. Is very easy to understand, is very easy to visualize it, so it is widely used. Okay, but as a name says, confusion matrix, don't get confused, it's very easy to understand. So this is a very good graphics for confusion matrix. So when we put forward the output into confusion matrix, is assume that we have only two kind of output, positive or negative. So there are actual output, there's predictive output, right? So when the when so four types of output can be possible: through positive, through negative, false positive, false negative. Through positive, through negative, by the word says, it is the actual predictions. It means that the positive predictions are right, the negative predictions were right too. Okay, false positive, on the other hand, it says that the predicted value was positive but happened to be in actual it is negative. Okay, on the other hand, false negative, the predicted value is negative but in reality it is positive. So false positive is talks about type 1 error, false negative talks about type 2 error. I'm going to give some examples in the notes too, so hang on there. Okay, so just this is a just slide part of it. I'm going to share you a notes too, where I'm going to write some stuff so that you'll be able to understand a bit more better. So as the protocol goes, I have created a logistic regression program, which I'm going to again show you, but I'm just putting forward that I have done all those things, like for example calling the logistic regression, then putting forward in the train test plate, evaluating the both the train and test scores, and trying to put forward the confusion matrix and trying to understand whether the things what we have done make sense or not. So I put forward the confusion matrix at the end, right? This is the confusion matrix output. So in the notes I'll explain a bit more. So yeah, so basically in terms of as a key takeaway, I will say that evaluation is very important, because without evaluating you won't be able to understand whether given a model is a good model or not. Matrix selections is also very important. Based on what kind of error are we going to handle, is it a type 1 error or type 2 error, we have to showcase the respective matrix. Okay, in the notes I'm going to explain a bit more about it. Confusion matrix is very important to share the confusion matrix to your stakeholders, so that it able to able to have a proper transparency what exactly you guys are doing. Okay, so if you are able to understand all this data, it means that you are able to understand a matrix. If you have any questions anywhere, please do put in the comment, and I'll try to answer your questions too. Okay, see you in the note side. This is the notes part of it. So this is the first time I'm trying this. I think so this is makes much more sense, because when you put forward something in written, it becomes very easy to understand what's going on and all, right? So I'll do a very quick revision of the things what exactly we have done, and becomes easy for everybody to who is looking into this video. Okay, so this is the 7 day technically, and we are explaining the concept of model evaluation. Okay, so before I explain that, so technically let me put forward that we are in a concept of classification. Okay, classification is a part of machine learning. Okay, machine learning can be divided into two parts. One is supervised and other is unsupervised. I'm very sure a lot of people would already understand this, but I'm just making sure that the context for the people who don't understand this. Okay, so supervised can be divided into regression and classification. I'm explaining this because remember that when we think about model evaluation, it is a part of, technically we are trying to understand the concept of matrix. So matrix for regression and the matrix for classifications are different. Okay, so in classification we have few metrics like accuracy, precision, recall, F1 score, and very important, from based on which it calculates, it's called confusion matrix. I hope everybody understand this concept. If you have any problem if you don't understand this concept, then it's very difficult to understand the things which I'm going to explain later. Okay, so in classification problem statement, the first thing which I have taken is the model of logistic regression. It's very interesting that even though it is a classification problem statement, the word is there of regression, because what happens is that it technically re-establish, or it technically it re-evaluates, re-emphasizes the concepts of linear regression and tries to create the new model of logistic regression. Okay, so everybody knows that when we think about linear regression, okay, if these are some data samples, so I can create a best fit line. So this is something, it's very simple or very easy to understand. The equation for this would be y is equals to beta naught plus beta 1 x1. Okay, plus epsilon, of course. But once we do logistic regression, okay, logistic regression is a bit different. Technically, what happens is that we have this kind of data set. We would be able to use linear regression, but we use a concept called sigmoid. What it does is that it creates a line which goes exactly, passes through it and passes through this. So this equation is called sigmoid equation, which can be put forward as 1 divided by 1 plus e raised the minus x. Okay, so the output, technically what happens is that output is a probability, and if the probability is above 0.5, then we will say it is plus 1. If it is below 0.5, then we will say it is negative, or it is 0. Okay, So remember this equation. Let me rewrite this equation for you. So I can say that logistic regression equation, which stands for y is equals to 1 divided by 1 plus e raised to minus x. And if I elaborate this is nothing but e raised to beta naught plus beta 1 x1. Okay, if you see this equation looks very similar to the linear regression which I had already written here. Okay, so technically we take a log around it, and that's how this equation comes in the picture. Okay, so if this is the equation for logistic regression. If you have any question around the logistic regression, please let me know. I will do a full video around it. Okay, now when we think about accuracy, precision, recall, it is all part of it, or it comes through a concept called confusion matrix. Okay, it comes from the part of confusion matrix. If I want to create a confusion matrix, let's say for example confusion matrix happen to be we have only two discrete output, 1 and 0, assuming that. Okay, so I'll say the actual values, which can be positive and negative value can be 0. Okay, and then that can be predicted values, which can be also positive, which can be also negative. Okay, let's create a proper box around it. Okay, so the values within this, right, can be called as true positive. It means that the actual value was also positive, the prediction was also positive. That's why true positive. The prediction was also negative and happened to be the actual value is also negative. So true negative. So technically these two outputs are the good outputs. It means my model is doing a good job when it predicts true positive and true negative. It is predicting positive and happen to be it is positive in the reality. It is predicting negative, happen to be it is negative in the reality. So it is a good output. The problem is when we have false positive, and false negative. What happens when we have false positive and false negative is, so basically there is some kind of error for sure. So in false positive, what happens, it is a kind of type 1 error. If you don't understand what is type 1 error, you can always put forward in the comment to explain type 1 error. I will happy to explain you the type 1 error. And this one is type 2 error. Type 2 error, what type 2 error says that the predicted value is negative but in reality it is positive. Type 2 error says that the predicted value is negative and in reality it is positive. Reality is positive. Type 1 error is reverse. So type 1 error says that the predicted value is positive, reality is negative. Take an example. So take an example. Imagine that for type 1 error, we will say that happen to be there is a judge who um, who says that the verdict is scenario 1. There's a judge, okay, there's a judge who has given a verdict of guilty. But in reality, the person is innocent. So this kind of error is type 1 error. So technically I am predicting that it is positive, but in reality the person is innocent. This is a type 1 error. Now scenario 2. So what I am saying is that the given person, let's say for example this is for a patient. The patient has, let's say, cancer or not. So I am predicting the patient has no cancer in report, but in reality person has cancer. So if you see, both type 1 and type 2 can be very dangerous, okay, but there are few scenarios where we'll try to focus on type 1 error, and there are few scenarios we'll try to focus on type 2 error. For example, if you're creating a cancer based testing stuff, right, we try to focus on the type 2 error, because if you're not able to predict it properly, then it can be very dangerous for a patient, because cancer patient has a much higher chance if they are predicted much earlier. At the same time, if you're in some kind of judicial kind of scenario, so it is very, very important to identify the right person and put guilty charges on that person, rather than trying to give guilty charges on some innocent person. It can be very, very dangerous for that person, right? So depending upon the scenarios, we can put forward type 1 and type 2 error, okay. When we think about precision focus on type 1 error, recall focus on type 2 error, and accuracy technically focus on across the board, okay. So you need to understand this part. So accuracy formula states that true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Precision, on the other hand, says that true positive divided by true positive plus false positive. This one. Recall. Now you will be able to understand what would be the recall stuff. Recall says that true positive divided by true positive plus false negative. This part. Correct? And F1 score, on other hand, technically talks about it's a kind of mean between the precision and recall, okay. So it says that precision into recall divided by precision plus recall. Now if you understand this much, then I can say that you are able
you have understood the matrices which are there in the classification. Always remember, confusion metric is very very important. Confusion metrics, if you think confusion metric in terms of type 1 and type 2 error, it becomes very easy. People try to remember the whole concept, that true positive, true negative, false positive, false negative. Don't try to remember it. Try to understand with the examples, then becomes very very easy. For example, I have given two scenarios of one scenario for type 1 error and one scenario for type 2 error. Please put forward what kind of scenarios you would like to look into it, and if you have any questions, please let me know. Okay, so this is the notes what I'm talking about. What I'll do, I'll try to upload this, give this notes link to. Thank you guys. Divided the program in different, and I have loaded the Titanic dataset. So Titanic dataset, I have used a dataset which is already there in Seaborn. So I've used that dataset. I have taken the important features which are going to be useful for me. I have done the required labeling. For example, I have encoded the male into 0, female into 1. So I've done the required stuff for that. It becomes easier for me to do the modeling. Okay, so then I have taken my X and Y, my features and my output. Then I've done my train test plate, right? Then I've initialized logistic regression, fit my stuff. Then I put forward my crisis score, the confusion matrix and all, which is very straightforward, very easy to understand. Okay, so this is the confusion metric what I have got. So now the question for you is, what is my true positive, what is my true negative? So I can give you 2 seconds for this. If you want, you can pause and you can come back again. So my true positive is 40 and my true negative is 68. Okay, so in that way you can also do it at your side also. Okay, so if you want to answer this question, the next question is, what is my false positive and what is my false negative? Please put forward your response in the comment. I will say whether it's right or wrong. Okay, thank you guys.
If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight and tag a friend who should join us. Let's keep learning, building and growing together in the AI and AI space. Make sure to like, subscribe and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it is going to get better and better as we go. Bye.